Hello, everybody. I'd like to tell you an SLO story. I built and maintain a continuous delivery platform. It happens to be built on top of GitLab. It uses EKS, Elastic Kubernetes Service within AWS. You don't really need to know anything about how those things work. Hopefully, it'll all be understandable from context. I'm a one-man team responsible for supporting the platform. Because my customers have products in production that rely upon changes being delivered by the system, there needs to be a way to escalate for help when it breaks. My phone always being the first call for everything meant I wanted to be sure that escalations were appropriate. I mean, I care about the reliability of my software, and it's not all about ensuring I can get a good night's sleep. So I needed an SLO that I can use to trigger the automatic support call. And to get there, I needed to start with an SLI. What is the job to be done of the system? Why do my customers use it? My continuous deployment platform is operating normally when customers can schedule jobs. Done. Monitor in place. Nailed it. Thank you for watching. Wait, don't go. Smarty Pantses may have spotted a problem already. So I start to monitor whether my customers can schedule jobs, right? Not exactly. I'm an infrastructure person who sets up infrastructure. So I start to monitor the size of the available node pool. I have a limited number of nodes upon which I can schedule jobs. So if I run out of those, I can't schedule anymore. And that tells me my customers can schedule jobs, right? No, of course not. But it gets close and it was easy. So what's the problem? Here's the thing. We can call this important takeaway number one. Seriously, screen cap this one. I wasn't monitoring when the system was working. I was monitoring when the system was broken in a very specific way. So I start tracking this flawed metric, firing an alarm every time it hits 90% capacity so I can have time to react before it hits 100%. Pretty standard ops thinking. Wow, we hit 90% really easily, like every day. Sometimes if I did nothing, we wouldn't cap out and would scale down naturally. So 90% was not the right value. Now, here's where I default to wanting my SLO to be like 99% because I can't brag about only 1.9 to the other platform engineers, but my node pool size is 40, so I can't discretely measure 99% of this because I can't have 39.6 virtual machines. So it's 95%, yeah? 1.59s, 38 nodes. Let's set an alarm when we hit 38 nodes. I do that and cool. It fires less, but still a lot. I have less time to react and we cap out at max nodes more often, but my customers aren't complaining. Why aren't they complaining? Here's how I figured this out. Let's look inside the scheduling and scaling system. Orchestrators called runners pull for work. Chicken schedules tiny bits. Francolin schedules larger bits. Quail schedules the largest things. If the scheduler cannot place a requested workload, it asks AWS for more nodes. Those soon come up and it tries again. This is almost always a delay and not a failure. Notice how I said almost always? We'll be back here in a minute. Anyway, the rate of calling for more is not commensurate with the mathematical capacity needed, meaning we could hit 40 and only actually need 37 to schedule all the work. If the work does fail to schedule, it's because of a timeout where the scheduler gives up. It then logs a message like failed to schedule. How often did this happen? Once ever during the time I was alerting at 95%. Aha, the message tells me when we actually failed. I could monitor these logs for that message. Smarty Pantses will notice none of this has solved the problem. Now, instead of being over notified, I was now being under notified. Let's go back to that pie chart. I reduced my known failure condition to a tiny sliver. By the numbers, the system was rock solid, but I still occasionally had escalations where customers were not getting what they wanted from the system. Here's the view of the system. Our customer pushes a job in GitLab, runners pull the job, push it to the scheduler. I was only monitoring this last piece. When, for example, the runners failed to talk to GitLab, I wasn't monitoring for that. Somewhere in here, I had an epiphany. My SLI isn't whether customers could schedule work, but rather if the system could complete requested work. If my system were the post office, I was only measuring my ability to put stamps on things and put them into a bin. If that bin caught fire, that didn't impact my SLO at all. The need to measure the job request all the way through to completion was a bit more challenging than looking at any single existing log or metric. Enter drones. I developed a set of hooks so I could define a bunch of drones as script plus schedule, and they would enter the same front door in GitLab as my customers' workloads, go through the entire scheduling process, incomplete or not, at regular intervals. I'm likely not the only one here today talking about synthetics, but I'm here to say that they can definitely be applied to a complex system like a continuous delivery platform. So this is takeaway number 2. This is the runner health check drone. It has a schedule that creates a new job through the front door every 5 minutes. Each job then runs for 5 minutes and schedules a child job again through the front door every minute. The child jobs each get scheduled and report affirmatively healthy to our logging/monitoring platform. So every minute, through a combination of short-lived and longer-lived jobs, I get a report of success. Any missing minute logs count as an error against my SLI. So that's where we are today. I'd also like to point out that imperfect measurements weren't useless measurements. Let's call this takeaway number 3. We uncovered and fixed many reliability issues along the way. The manual firefighting I was doing here with freeing up capacity on the nodes, I automated it. We had zombie jobs eating up resources. We ran up against API throttling twice. We got cut off from registering more ephemeral runners because we had added too many to the database. We were auto-scaling nodes down and terminating expensive jobs before they could finish. Each one of these we now monitor and remediate, usually with a drone. So we're still identifying and handling the known failure cases before they become big problems, but they're no longer the thing we use to measure our SLI. To recap quick, here are the 3 big things I learned about reliability measurements since building the system. First, measuring known failure cases is not the same thing as measuring success. Second, synthetics can be used in complex systems. They just need to be designed well. Third, less than perfect measurements are still useful. If you're not sure what to measure or how to measure the perfect thing, start with what you can and see what you can learn. You usually only have one chance to capture data, so start measuring your systems and you can iterate and get better. Embrace continuous improvement in your systems and all their aspects like monitoring. Thanks for watching. For real this time.